Okay, here's the deal. My name's Vinny. I'm gonna be your host for today. What we're gonna do here is, I think last time they did a circle collisions. At least that's what I was told. So today, we're gonna try to do some actual bounding axis aligned bounding box collisions. So that's what we're gonna get into today. That's going to require us to do a few changes to some of our modules and such. So let's get into that. The first thing I want to do is let's change a little bit of, let's add some stuff to Vector 2. And what I want to add to Vector 2 is we want a way to subtract. We're going to need a way to subtract a couple of vectors. So we'll do this, return something, and we'll say end. So what we're going to return is we're going to return a new vector, v1.x minus v2.x, and v1.y minus v2.y. So easy, simple subtraction, right? Okay. We're also going to want to be able to add. We'll see, we got subtract. We need add. So let's copy. Stupid thing. Let's copy this one. Let's put it up here. And we'll do add. And we'll just change these minuses to a plus. Real simple. Anybody could do it, right? Even a caveman. So we've got add, subtract. And let's put them in order. Add, subtract, multiply. And that one actually multiplies. See, these two return a new vector. This one actually multiplies the vector itself. Okay, well, we'll leave it that way for now. And I'm going to do a divide. And we'll say divide by whatever. And for this one, I'm going to also return a vector self.x divided by value, self.y divided by value. And, you know, one could come in here and say, also assert value is greater than 0, error, val must not be 0. So we would say not equal to here. And let's go ahead and return a new vector up here too, for now, just for now. So this will be multiply and multiply. So that we're all consistent. We're returning a new vector anytime we do the addition or subtraction. That looks wonderful. I think our vectors should be good. Now, something we've been playing with this whole time is the this idea of a rectangle, this rect here, and we've sort of been just defining it on the fly as something with a width and a height and an x and a y. But let's make it real, shall we? Let's make it something real. So let's make a new file. Call it rect.lua. We'll go in here and let's just look at a different way to do a module instead of sort of like a class type module without using our class function or our class module. So we're going to define a local table. We'll call it rect. And you'll see that the class module here does very similar things, actually. We're doing very similar things to this. But we want to give it a, well, we could just go ahead and derive it from class. Why don't we do that? We'll be consistent. Never mind. Never mind. These aren't the droids you're looking for. Move along. Move along. So we'll just go ahead and grab this stuff and shove it in here. Shove it in here. And I'll need the vector class also. We'll probably need that. We won't need state machine or animation or sprite. And let's see, we'll do rect. And we'll return rect as we normally do. And we'll do rect here. We're not gonna I mean, we could just do this regular and not do this whole class thing here, because rect is just a really simple, it's a really simple thing. We'll leave it this way for now. So we say function, let's do R. It's easier to type, it's faster. I'm on a tight schedule here. R colon new end, and we'll say rect. So the first one you're going to create will have an x, a y, a width, and a height, and where x comma y indicate the upper left corner of the rect. Okay, and we'll say self.x equals x or 0, which we really don't have to do, but we're going to do that. And then self.width equals width or 0. Why would you want to have a 0 height and a 0 width rectangle? I don't know, but you can. In addition, I want to have another function that we're going to call r slash or r, we'll have a dot, create centered. So this will have an x, a y, a width, and a height. But this one, where comma y indicates the center of the rect. So we will just say local r equals r x comma, well, actually we'll do 0 comma 0 comma width comma height, and then we will eventually return r, and then we'll say to do we'll do something like, we want to do something like r, like set center, and we want to set that to x comma y. Let's go ahead and implement that. So what I want to do basically is I want to be able to create a rectangle, a regular rectangle like we normally do with x and y in the upper left hand corner, and then I also want to do one additional one called create centered, where the x and y now indicate the center of the rectangle. So let's do, first of all, let's do a function that we just put up there in parentheses called set center. We'll do x and y. And that's really just going to be self.x is going to be equal to x, which is where we want the center, because yeah. So we're going to be the center. I'm going to self.width divided by 2. So we are saying I want to set the center, but our actual center is going to be, we're setting the center, but our actual x and y are going to be upper left and upper right hand corner. That's upper left hand corner point. So that's what we're doing here. We're translating the center x that we're setting into what we say is actually our upper left hand corner. So that's what we're doing here. Yes, that's what we're doing. Hey, are you sure they're going to understand this stuff? I mean, it's pretty complicated. Yeah, they'll be fine. It's fine. Let's also, since the center is going to be a different thing than just the x and the y, let's go ahead and let's get a vector 2. Let's return a vector 2 when they ask for the center of self.x plus half that width, self.width divided by 2, self.y plus self.h divided by 2. Yes, this looks fantastic. So now we can get the center as a vector, and then we can set the center of the rectangle, and that's going to be important for us. In addition, let's go ahead and create another function called max, and that's going to return to us a new vector 2 that basically gives us the lower right hand corner. So with 2 points you can describe a rectangle, which is what we're doing, where we want that maximum point, and that's just going to be self.x. Actually, let's just copy this, because it's going to be this, but it's going to be this plus the full width and the full height. So that'll give us that bottom right hand corner. And then, yeah, I think that's probably good for now, don't you? So then let's come into our sprite, because we now no longer want to return this blah 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 table, just that plain old sort of on the fly table here. Let's return an actual rectangle that we have just defined, the rectangle class. So lib.rect, I'm going to just include that there. And let's come down here and we'll say local, actually we can just return it, return, and we'll say rect, and then we're going to use create centered, because that's what we're doing here. See, we're moving the, you'll see. We just want a self.position.x. Remember, because our sprite is actually centered, that self.position.x and y are the center positions. And the width is going to be this scaled width, and the height will be this scaled height as well. So that, let's see if that actually runs, or if we've screwed something up. And we have, let me turn off that. So global, what did it say? I wasn't even paying attention. Vector 2 Lua 18 vec, return vec. Oh, of course, not vec, it's vector 2. That will just, and there's another one here I missed, and another one here, and another one here. My goodness. Let's just do this. Go all the way down through here. Let's just make it V. V for vector. And what do we have here? Rect Lua 21. Oh, yes. I missed this. And look, I did it here too. I'm just talking. You're probably yelling at the screen the whole time, but don't worry, we'll fix it. Utils Lua 32. Yes, Utils Lua 32. What do we have here? Rect. What was it? 32 was. Well, we should have. So we have converted it. We have self.x, self.y, width and height. So let's look at that again. Utils Lua 32. And where did it come from? Test Lua 29. Oh, that's why. Well, we need to do this, don't we? We need to do that because we never did set the center, so that's why that's not good. Okay, now we've got an attempt to perform arithmetic on field W on the rect class. Okay, so where are we? What are we doing? Rect Lua 26. And function update test Lua. Where? 29. No, man. No, man. Function set center, rect Lua. Okay. Huh. $17. Oh, yeah. Sorry about that. Gotta have the lowercase there. So now we're back to this one. Attempt to perform a arithmetic on field X, which is a nil value, which is not true. Self I with X, Y with height. That looks good to me. You know, it really looks good to me. I'm not sure. Let's do this just for fun. Let's sort of indicate this is center X and center Y, and there our problem is right there. Forgive me, I'm trying to go much too quickly. So now we're back to the way we were. We have our new rect class now. Let's see what else we can get into. So what we want to do is we want to determine when those rectangles are colliding, which we're doing that, and now we also want to do that minimum separation axis. And in doing that, we want to determine the minimum point on the bounds of that colliding, of that rectangle that we are not going to move, in which we need to push back. Again, remember the circle example that we did last time. Well, I was looking around at some research, and there's this really interesting geometrical method that you can use. It's called the Minowski addition, and there's Minkowski differences. So these do interesting things to the different polygonal shapes. And it turns out that these can be used to do collision detection. Very, very interesting, right? So what I want to do is I want to use this because it actually makes it fairly simple to do this. And I found this really great article here, and I'm going to actually refer to it here. We'll put it in the comment for a good article on Minowski sums, or using Minowski sums differences to determine separation. Sure. See this article. Okay. So bottom line is you can actually create these. You can do a Minkowski difference between some of these axis aligned bounding boxes, and you can do the calculations as shown here. And so that's what we're going to do real quick. We're going to add that to our rect class. We're going to do a Minkowski difference. So Minkowski difference, and then we'll do a other, and we'll say other is also a rect. And we won't check that for now, but we could check it. So we want, as we see in the article, which I will pull up, just put it here, and then we'll do this. So we want basically the left. So we'll say we can actually say the top left. So we'll do top left. You see, this is the X and the Y is what he's doing here. So we'll say top left equals, and now we can use our fancy vector2 dot sub. And did we make it? We actually have a colon there, don't we? Let's put a dot so that we can do it either way. We'll go ahead and just do vector2 dot sub. You see what I did? I just added a dot instead of the colon, but you can still call it with a dot, with a colon, and it will work. And these do require that, but these two are just sort of generic functions that don't necessarily belong to any instance of our little module. So we're going to do vector2.sub, and we'll say we want the what we call, remember, the min, which is basically the x and the y of our rectangle, because that's what we're returning in as a vector here. So we want to subtract from the min. We want to take the other and subtract the max from that. And so that's going to be our new top left. And additionally, we want to do the same thing, and we want to get a new size for this thing. And again, these Minowski stuff is really weird. It's kind of weird. I mean, the math looks simple enough, but as far as understanding it, I haven't really gone into it and really read some of this stuff. But it's really cool. It's really cool how it works. So if you want to check these pages out, because they're really, it's a really interesting process. I'm going to have to look at it some more later. But in any case, we want to get the job done right now, right? Don't we? So the new size. What we really need, we want a vector here, because we're going to have to add all this stuff together, and it's just easier to just say size, and then we'll just say end, and we can return a vector2, and it's just going to be self.width, self.height is all that's all it's going to be. See what I did? That way, the new size is going to basically be a vector2. We're going to add it. So a Minowski difference between two shapes, or at least two rectangular shapes, is going to be the sum of their sizes. So we'll do this. Isn't that strange? Yeah? I think it is too. And then we'll have, that's a top left, the new size, and then we'll have a new left. We'll have a new left-hand corner. And that's going to be vector2. And if you look, let's see, where are we? Actually, right here. So we're going to do a new left, which is going to be basically we're implementing. Yeah, this will be our new left right here. But we're gonna use that as a separate step. So we're going to add our top left and our new size. So basically what we want is that we're going to divide that by 2. So basically we're going to go in, or we're going to do half of it. It's almost like going back into the center of it. And then we'll say, we'll call it, actually we can just, let's return, and we'll say r dot create centered, right? We'll say new left dot x. So we're kind of doing this right here, right? But we're creating it centered, which is what he's doing here. He's saying, I want that to be the center. I think that's what he's doing anyway. We'll see. New left dot y. And then, of course, the size is going to be the new size dot x. And new size dot y. Okay, cross your fingers. Hopefully that's correct. So that gives us the Minowski difference between two rectangles. All right. So let's go ahead and prepare our test scene for this very thing, shall we? Let's see, what are we doing? Okay, we're good. We're good on time. Let's do the following. Let's pull these out. Right? So let's call this local R1 equals this, because we're going to use these again, and we don't want to keep calling it and creating new ones, right? So local R2, this is where we're gonna just test for these two here. So if they collide, then we're definitely going to want to say get a Minowski difference between that R2 and so we'll say Minowski diff, I believe is what it was, between R2 and R1. So that's our Minowski difference. And then we're going to want to get, and let's go ahead and set this up here so we can get that out of the way. So then we're going to want to get that closest point on the bounds of this new Minowski, this new rectangle thing that we created by doing the difference between these two things. I mean, if you look up here, you can actually check and see if the two rectangles collide by seeing if the point 0, 0 is contained within the new rectangle. That's really strange because I don't know. It works. It's a property, so you can test for that origin. And that's kind of what we're going to do here. We're going to get the closest point from the origin to the edge of our new Minowski differenced rectangle. Really strange, I know. I mean, if we want more explanation, hey, we can do a video about it. I have no problem with that. We can do it. But for now, we're just going to make it work, right? So what we need is, we need something called closest function. Closest point on bounds. Let's call it that. And then we'll feed a point into it, okay? So he's actually given us, in this lovely dissertation here, he's given us kind of the way to go here. So he's basically showing us how to do this. So he's saying the minimum distance. So he's doing a first calculation. He's going to look at x first. He's going to check the x penetration first. And you see he's using an absolute value. So I'm going to come up here and I'm going to say local ABS equals math.abs, just because it's quicker, easier to write. So we're going to do absolute value of point.x minus, and then, so we want the min, so let's do a local min. Actually, we don't necessarily have to do that, do we? No, we don't, because we only really want, if you see what he's doing there, we only want the minimum of whoops, right here, the minimum of this current one, which ends up just being that x. Remember, because it's top left, which is the minimum for both, since y gets bigger when it goes down, so that will be fine. But let's go ahead and create a max. We're going to need max, because you see he's referring to max right here. We can just do self.max, and that's why we went ahead and defined that. It's useful in other ways too, of course. We can find many ways to use that. And then we'll go ahead and, assuming that this all works out, we're going to calculate an initial bounds point. Right? And that's going to be a vector 2, and we'll call it self.x point.y. I know, strange, really weird. Again, we're not going to explain it. Like I said, if you're interested in getting an explanation, maybe we could do a video if enough people are interested in that. But so we're going to follow what he's doing here. So he's now doing the check for still doing the check for x. So he's checking to see if the absolute value of that maximum part of x, so the right side of this new Minowski triangle, or Minowski triangle, this Minowski rectangle, subtracting from this point that we want to look at to see the closest point on the bounds. We want to see if that is less than this minimum distance. And if it is, then we're going to have a new minimum distance. Minimum distance. And that's going to be the same as this. Just like that. And then our bounds point is going to be different now. We're going to change our bounds point, and that's going to be a vector 2. So we're going to say that's going to be max.x and still point.y. So we check the x's first. Finish checking x-axis. And now move to y-axis, which is what he's doing in these. And at the end, let's go ahead and do that. Return bounds point. Right. So now let's do that part. So he's saying, he's checking y, so he's saying if the absolute value of max.y minus that point.y is less than min distance, then he's going to say that min distance is equal to that. Fairly simple, right? Min distance is equal to that. And then again, he sets the bounds point to something different, which will copy this one to get all the typing. And that's going to be point.x and then max.y. And we're getting close. And then he's got one more check, which we'll just copy the previous one. We'll modify. He's looking at min.y, point.y, and it's going to be min.y, point.x, and min.y. Oh, I'm excited. Does it run without errors? It's running without errors, but that doesn't mean it works yet. Now let's go to test. We have that Minowski difference. Oh my. Then we can say that local, let's call it the separation vector. We'll say the Minowski difference rectangle, and we'll say closest, what is it? Credit, I don't remember what we called it. Closest point on bounds. Closest point on bounds, like that. And here, what's fascinating is we just want to pass in an empty vector 2. So we're looking at 0, 0 origin. We want to go for the minimum point from the origin to the side of this Minowski rectangle. And that's going to end up being our separation vector. So then we can say self.p for the player, the sprite dot, I think it's position dot x is equal to that. Dot plus the separation vector dot x, and we'll do the same thing for y. Let's get that done. Let's see what we get. Probably going to be some errors here, so let's run into it. Yeah, min. Did we not do min? Attempt to call min a nil value. Oh yeah, no, we did. Yeah, sorry about that. We don't need min. We need. Remember, the min was actually self.y. Do we have any other place where we have min? Yep, right there. Let's see what happens now. Let's see if it works. Attempt to call min rect 45. 46, 45. Oh, we don't have a min. Let's create a min. We do need one because it's easier. We want to create a vector quickly. So we're just gonna create a min, which just returns self x and y. That way we can just get on with it. And vector 2. Where is it? Attempt to vector 2 Lua 19. Oh, and that is where? Minowski rect 51. So I must have an issue there. Come here. 51. Oh, they're right there. I misspelled it there. So let's see what we get now. We'll have to walk him all the way over. Let's see if, okay. Test. Attempt to call global vector 2 a nil value. So that's in test, and we must not have defined vector 2 in test. No, see, we didn't. Let's fix that. Run it again and see if we get it or not. Attempt to index a global min rectangle. Forgive me for all of these errors. Let's see, 72. Here. Yes. Another one that I missed. Let's check it out, see if it works now. There we go. And we're good, ladies and gentlemen. You see, we now collide and correctly respond. We'll clean some of this up next time, but in the meantime, I hope you enjoy it, and perhaps you will take a look at this article and maybe some of the Minowski stuff and learn some more cool math. Until next time, I'll see you later.